Hello everyone, I am Riya Zachariah, a management team member of Codezilla. Hope all of you are doing well and are using this pandemic time effectively. Today, we will be discussing about quantum computing. What is quantum computing? We've all heard of words or concepts like cloud computing and quantum physics, etc. Most people would have never put the words quantum and computing together. And on hearing this concept, what springs to mind is the combination of physics with computers. And this is essentially what quantum computing is about. It is a new and exciting field at the intersection of maths, physics, and computer science. So let's dive right into it. We experience the benefits of classical computers every day. But there are challenges that today's systems will never be able to solve. And that is when quantum computing comes into play. Quantum computing is the use of quantum phenomena such as superposition and entanglement to perform computation. Computers that perform quantum computations are known as quantum computers. We will learn about superposition and entanglement further into the discussion. But first, let's look at why we need quantum computing. Quantum computers can solve some of the toughest problems and have the potential to solve some of the world's most complex programs. These problems are beyond the reach of even today's most super powerful computers. This is because quantum computers have the potential to process exponentially more data compared to classical computers and supercomputers. These computers work differently from a normal computer. However, it is important to note that quantum computers are not going to replace classical computers. Their radically different way of operating enables them to perform calculations that classical computing cannot. So let's see how quantum computers differ from classical computers and how they work. The working of quantum computers. In normal computers, we all know that information is stored as bits, and each bit represents either a 0 or 1. These zeros and ones act as on-off switches that ultimately translate into computer functions to perform simple calculations. And this happens. Let's look at how this happens. A classical computer would test each possible route one at a time to find the correct one, resulting in us getting an output. But this results in classical computers being able to solve only one problem at a time. Quantum computers, however, use qubits. A qubit, in simple words, is a mixture of both 0 and 1. Qubits make use of two key principles of quantum physics: superposition and superposition entanglement, like we saw in the definition of quantum computing. Let's look at these two terms a bit more closely. Superposition means that each qubit can represent a 0, a 1, or both at the same time. Entanglement happens when two qubits in a superposition are correlated with one another, meaning the state of one qubit, whether it is a 0, a 1, or both, depends on another qubit. Using these two key principles, qubit can act as a much more sophisticated version of switches, helping quantum computers solve difficult problems that are impossible to do using classical computers. Let's look a bit more closely at what a qubit is. As you can see in this picture, we can see the difference in representation between a bit and a qubit. The qubit state is a combination of the values along all three axes, that is x, y, and z. This is called a superposition. Like we saw earlier, a superposition means that the qubit can be 0, 1, or both at the same time. Some people describe this property as being in all possible states at the same time. The 1 and 0 of the qubits can be represented by the spin up and spin down states of an electron, or by the spin states of the nucleus in an atom. A quantum computer can actually do math and solve problems on the qubit while it is in superposition, leading to a quantum computer being able to solve multiple problems at the same time, something that a classical computer could never do. This is the picture of one of the most earliest developed quantum computers. This was developed by IBM Research in Zurich, Switzerland. The quantum computer was first created, however, in 1998 by Isaac Chuang from MIT and Mark Kubinek from the University of California. Let's look at some of the applications of quantum computing. Quantum can be used for AI, for molecular modeling, for cryptography, for financial modeling, and for medicines. We will look into some of these topics very briefly. Quantum computing could lead to the discovery of new medicines and materials. How? By helping us untangle the complexities of molecules and the chemical interactions between the molecules. It will also help us to make better investments by finding new ways to model financial data. Quantum computing will be able to crack even the most sophisticated encryptions in minutes. This is because quantum computers work at an atomic level and can shortcut physical restrictions that affect traditional computers. This results in secure communication. Quantum computing is also ideal for solving problems in astrophysics, pharmaceuticals, and weather forecasting. Let's take a summary of whatever we learned in today's discussion. Quantum computing is the science that uses the law of quantum mechanics to enhance our communication and computational capabilities. A classical bit encodes information using 1 and 0, while qubits are a superposition of 0 and 1. Quantum computation requires fewer steps and can be faster. A quantum computer uses its entangled quantum state to find the correct route quicker with far fewer calculations. Think of it in this way. Technologies that currently run on classical computers can expertly find patterns and insights buried in vast amounts of existing data. But quantum computers will deliver solutions where patterns cannot be seen because sufficient data does not exist. Sometimes classical computers are not able to discover an optimal answer because the possibilities are too enormous to ever be processed. And this is where quantum computers come into place. Quantum computers won't replace our everyday computers, but its ability to solve complex problems will open up a new universe of information, transforming our view of the world and the way we navigate. Thank you. Hope all of you enjoyed today's discussion and learned a few new things. Please don't forget to like the video and follow this channel for more such content. You can also follow these social media handles for updates. Goodbye.